Good morning. My name is R. Sricharan and my roll number is 5D1. Today, my topic is operating systems research for reconfigurable computing. From their original use as replacement components for discrete digital chips, failed programmable gate arrays have transitioned through interesting and rapid role changes. These changes have in turn driven changes in operating systems research as well as in the past future. OS research in reconfigurable computing will continue to be influenced by change. However, research directions are no longer diversion by just evolving roles of FPGA devices, but by much broader events occurring in a general purpose computing community as well. In the early days, the reconfigurable computing FPGAs were transistor limited and rather simply. Operating systems research started along two paths. Along the first path, the FPGA was used as an application accelerator. Brenner was one of the first to argue the benefits of bringing an FPGA under existing OS. He argued that the FPGA should be treated like addressable memory or another external I/O device. During these early days, researchers recognized a unique potential of an FPGA, the ability to allow a potent of the chip to function while another program was being reprogrammed. This began a research agenda in dynamic scheduling of hardware accelerators that continues today. Along the second path, FPGAs were used to continue earlier exploration in the hardware software design of real-time operating systems such as the VLSI scheduling corp- corporation in the Spring kernel. Leiden was one of the first to use a FPGA as a coprocessor to host a low latency determinant real-time operating system. Diesel Diesel gave a nice coverage of the arrays. Overall, operating system research changes fine. As platform FPGAs were maturing, a significant paradigm shift hit the general purpose computing community. Implicit instruction level parallelism within a scalar processor gave way to explicit programmer specified parallelism across scalable numbers of parallel process. Analysis shows that research events 1990s emerging FPGA platform, Cricket 2000 dark silicon and emerging chip heterogeneous multiprocessor enable concurrent software programming models across boundary application accelerator for CPUs. Research that may prove relevant to this problem is coming from a renewed interest in building more self-awareness, runtime, adaptivity, and dynamic tuning within the operating system. Techniques currently being explored to multiprocessor recent self-aware techniques currently being explored to adaptively increase performance as well as dynamically. Trend of performance and power OS to explore computation across the software hardware boundary adaptivity, increasing overall system performance along different avenues. Whether dynamically reprogrammed parts of the FPGA would increase energy efficiency. This investigation yielded early into how the OS can migrate protons of program around the and between different heterogeneous resources. Importantly, they laid hope for further programmers who would like to write code once and run it anywhere, particularly between systems with hundreds of different combinations and types of heterogeneous process. For FPGA based heterogeneous multiprocessors, that the choice of anywhere is vast and growing potential resources include different types of general purpose extensible vector and GPU processors as well as a custom hardware based accelerators within an FPGA. The OS already has the opportunity to move its resources into and out of the hardware as if they were virtual page being swapped into and out of a main memory. The move towards self awareness implies the OS may need more interruption or ability to for exploring new hardware software flexibility. The successful outcomes of these types of research exploration may offer an alternative path of promoting architectural details up into the user code. What forms of new abstraction and OS capability that might eventually evolve as FPGAs have changed, so as a focus of operating system research within the comparable computing. Our research questions are now shared to general purpose computing community where the goals was once to simply use existing being a new position of helping define the look and feel next generation operating systems. Only time will. Thank you. ఎవరమ్మా